Hi, welcome all. Today we shall discuss about mathematical operations on NumPy arrays. Okay, first let us consider arithmetic operators. And we have four arithmetic operations: addition, subtraction, multiplication, then division. Now let us define this operation in general. Say A operation B. So this can be any arithmetic operator like plus, minus, star or slash. So this operation has two different possibilities. One is both A and B are of same dimensions and both A and B are arrays. So this is the condition. If A and B are arrays of same dimensions, then it retains an array obviously of the same dimension obtained by adding or subtracting or multiplying or dividing the corresponding elements of the array. That means 0th element of A and 0th element of B are taken and this particular operation is performed. Similarly, this will be performed on all corresponding elements. So Aij operation Bij gives ijth element of the resultant array. So that's the idea. For instance, if I call C is equal to A operation B, then Cij is equal to Aij operation Bij. So this is the operation, arithmetic operation. And what happens if either A or B is a scalar? Then it returns an array obtained by performing that particular operation on each and every element with the scalar. For example, if I multiply a particular array with 2 is a scalar, then every element is multiplied with 2. That means every element is doubled. So that's the idea. Okay, നമുക്ക് arithmetic operations on arrays പരിചയപ്പെടാം. അങ്ങനെ ഞാൻ ആദ്യമേ numpy import ചെയ്യുകയാണ്. As we always do, let us import numpy as np. Okay, numpy is ready. So let us first create an array. So for that, say A is equal to np dot arrange some 6. So I'm going to construct an array A having 6 elements, say 0, 1, 2, 3, 4 and 5, and I'm going to change the shape. A dot resize, I'm not reshape, okay, let us resize so that it will be permanent, and the new size is say 2 by 3. Now you can see what A is. Now let us create another array, say B, which is equal to np dot arrange. So let's start with 10 and we'll have some 6 arrays, so up to 16. Now let us see what B is. So there are 6 elements, 10, 11, 12, 13, 14 and 15, and I am going to resize it, resize to a new size, say 2 by 3. Okay, so this is B. So we have just created 2 arrays, namely A and B. Both are 2 by 3 in dimension. There are 2 elements in the first axis and 3 elements along the second axis. I'm sorry, first there are 2 elements along the 0th axis and there are 3 elements in the first axis. Okay, now let us first consider what addition is. So A plus B, here both A and B are arrays of same dimension. So when you add, the corresponding elements get added. See, the first element 0 0 element is 0 for A and 10 for B. So adding, you will get 10. Next 0 1 element is 1. 0 1 element of B is 11. Adding 1 and 11 will get 12. Similarly, the corresponding elements, for example, the 1 2 element is 5 for A and 15 for B. Adding will get 20. So this is element wise operation. So when both the operands are arrays of same dimension, element wise operation is performed. Correct? Now let us see what happens if I add a scalar to A. Say I'm going to add 1 to the first array A. So A plus 1. So you can see that 1 is added with every element. So this is what happens. Okay. So similarly, you can try other operations. Randomly we will do some operation. For example, A star 5. So we know what A is. A is 0, 1, 2, 3, 4, 5. And I'm going to multiply with 5. So on multiplying, 0 into 5, 0. 1 into 5, 5. 2 into 5, 10. Like that. Okay. അപ്പോൾ element wise ആണ് വേണ്ടതെങ്കിൽ ഇങ്ങനെയാണ് ചെയ്യേണ്ടത് operation. So there is one problem with A star B. Okay. Here the problem is this. When you multiply A star B, it is just like matrix multiplication. എന്ന് നമുക്ക് ചിലപ്പോൾ തോന്നും. കാരണം A ഒരു സ്കെയിലർ ആണ്, ഇത് സോറി A ഒരു array ആണ്, P is another array. So when we multiply, basically what happens is the corresponding elements are multiplied. So we will make it more clear. So this is A and this is B. So 0 into 10, 1 into 11, 2 into 12, like that. That is A star B. So we will display that. So A is 0, 1, 2, 3, 4, 5 and B is 10, 11, 12, 13, 14, 15. Now what happens when A is multiplied with B? So this is 0, this is 10, so 0 into 10 is 0. Then 1 into 11 gives 11. Then 2 into 12 gives 24. So on and so forth. Okay. So next operation is dot product of two arrays. So it returns the dot product of A and B. If A and B are both scalars or one-dimensional arrays, then a scalar is returned. Otherwise, an array is returned. So we will see all these possibilities through examples. So there are these possibilities. If A and B are one-dimensional arrays, then the inner product or the dot product of vectors will be returned. If A and B are two-dimensional arrays, it's then matrix multiplication. And if either A or B is zero-dimensional, that means scalar, and it is just equivalent to multiply. So we will see all the three possibilities through example. All right. നമുക്ക് അടുത്തായിട്ട് dot product dot എന്ന് പറയുന്ന ഓപ്പറേഷൻ പരിചയപ്പെടാം. ഇപ്പോൾ numpy smp. Now we will create two arrays. Say A is equal to np dot array of 1, 2, 3, and B is equal to np dot array of say 5, 6, 7. All right. Now let us see what A and B are. Okay, they are basically arrays. Now let us multiply. Let us use the dot product in different ways. So we have to first consider when both A and B are one-dimensional arrays, what will be the result? Okay, so here A and B are one-dimensional arrays. Now let us recall how dot product is defined as. This is considered as A1, A2 and A3. If you call this as B1, B2, B3, then A dot B is defined as A1, B1 plus A2, B2 plus A3, B3. That means 1 into 5 plus 2 into 6 plus 3 into 7. So let us see what our result is. np dot of A comma B. So 38. So we'll verify it. 1 star 5 plus 2 star 6 plus 3 star 7. So this is the dot product when both A and B are one-dimensional arrays. Please note that the dimensions must match. That means if there are 3 in the first, then there must be 3 elements in the second as well. Now you can have more than 3, no issues. You may try that. Okay. The next possibility is if both A and B are two-dimensional arrays, then it will be matrix multiplication. So for that, I'm going to create two arrays, say X and Y. X equals np dot array of two-dimensional arrays are list of lists. Say 1, 2 is the first row, then 3, 4 say the second row. So this is our X. Now let me create Y, again a 2 by 2 matrix. Okay. np dot array of, so 3, 8, 4, 9. So I just created two arrays, 2 by 2 arrays. So let us see them. X is like this and Y is like this. Now let us find out the dot product. So np dot of X comma Y. So I already told you it will be matrix multiplication. How it is performed? 1 into 3 plus 2 into 4. So 1 into 3 is 3, 2 into 4 is 8, then 3 plus 8 is 11. So that will be the first element. You know how matrices are multiplied. So try to multiply and verify the result. Okay, fine. And the next possibility is the arguments, namely A and B, can either be a scalar. That means 0 dimensional. Okay, so we'll consider that also. So np dot of, say X, or say A comma 2. Okay, so let us recall what A is. A is 1, 2, 3. Then dot of A comma 2 is obtained by multiplying every element of A with 2. So that is the rule. So if either of A and B, A or B, is 0 dimensional, that means a scalar, it is equivalent to multiply. Fine. The next operation we have to discuss is the cross product. So this is used to get the cross product of two vectors. Okay, or arrays of vectors. Either two vectors or arrays of vectors. So we shall explain through example all these possibilities. ഓക്കെ, നമ്മൾ അടുത്തതായി ക്രോസ് പ്രോഡക്റ്റ് പരിചയപ്പെടാൻ പോവുകയാണ്. അതിനെ ഞാൻ ഓൾറെഡി രണ്ട് അരേകൾ ക്രിയേറ്റ് ചെയ്തിട്ടുണ്ട്. എ ആൻഡ് ബി. എ ഈസ് 1 2 3 ആൻഡ് ബി ഈസ് 6 5 4. അപ്പോൾ വി കൺസിഡർ ദിസ് ആസ് I plus 2j plus 3k and this vector as 6i plus 5j plus 4k. Now let us calculate the cross product. So when a and b are two vectors, then the cross product of two vectors will be perpendicular to both a and b. So cross of a comma b. So you can see the cross product. So please verify this result. 1 2 3 6 5k. Hope you remember how it is calculated. It is calculated as determinant ijk 1 2 3 6 5 4. So you know how to calculate it. Then this has to be considered as negative 7i plus 14j minus 7k. All right. Now this need not be always a three component vector. You can have two component vector as well. So automatically it consider the kth component or z component as 0, and obviously the result will be along k. So we'll check that. So we'll see a as 1 comma 2 and this is b, then let it be 1 and 2, and then a has some two comma 1. And you can see that this is 3. That means the vector is 3k cap. So you can verify that as well. Okay. To make it more clear, let us find out what is I cross j. So for that, let a is some 1 0, and say b as 0 1. So it is I cross j. So the result is obviously k. So let us find the cross product. So it is 1k. So when the length are 2, then obviously you will get the z component alone. Okay. So what happens if this is a two-dimensional vector? Okay. So for example, say x equals np dot array of the first element is say 1 2 3, and the second row is say 6 5 4, or let it be 6 5 4. Instead we choose some other values, say 8 comma 2 comma then 1. So this is my x. Now I'm going to construct another vector, say y, which is some 6 comma 5 comma 4, and the other one is some random, say 2 comma then 1 comma 7. Okay. Now I'm going to find out the cross product of x and y. See how this cross product are evaluated. So it is evaluated along the last axis. So we will see what is the last axis. So this is the 0th axis and this is the first axis. So the last axes are 1, 2, 3 and 8 to 1. And similarly for y, the last axes are 6, 5, 4 and 2, 1, 7. Please note that this is the 0th axis and this is the first axis. So please recall that when the dimension of either, the cross product of a vector, if A and B are arrays of vectors, the vectors are defined by the last axis of A and B by default, and these axes can have dimensions 2 or 3. Well, last axis which it is calculated. So last axis is the first row of this one. X in the first row cross Y in the first row. That is X cross Y in the first row. First row is the last axis. 0th axis is column. First axis is row. So result product in the result will be aligned along the last axis. And you can check the result. 1, 2, 3, 6, 5, 4 cross negative 7, 14, 7 negative. So the same result. So please note that the cross product is evaluated along the last axis by default. Both operand arrays in the last axis result last axis display. Okay, so if you wish to change the axis, you have this optional arguments. നിങ്ങൾക്ക് വേണമെങ്കിൽ A axis, B axis, C axis ഒക്കെ നിങ്ങൾക്ക് verify മാറ്റാം. ഇതൊക്കെ ലാസ്റ്റ് ആക്സിസ് എന്നാണ്. നിങ്ങൾക്ക് വേണമെങ്കിൽ ഈ ആക്സിസിനെ മാറ്റാവുന്നതാണ്. ഓക്കെ, റൈറ്റ്. Okay, so I request you to try with other vectors as well. Thank you. I request you to perform these operations on different arrays and try to explore different way these operations, namely arithmetic operators, plus, minus, star, slash, as well as dot product and cross product works. Thank you.